Hello all, welcome to my channel. I'm back with another video. In this video, we'll be going through what a Spark declarative pipeline is and how we can use it. So let's get started. So at a very core level, Spark declarative pipeline is a way for us to define what we want to achieve with a pipeline, and Spark figures it out itself that okay, what needs to be created, and then it executes that and keeps everything in place for us. So, for example, if this was not the case, let's say if Spark declarative pipeline was not there, how we used to do is we used to write our own code every time, and we used to keep on updating. We used to track that okay, all the dependencies are met in a different way. Uh, then we used to track what a downstream application needs to be triggered to see whether the whole pipeline goes through or not. Then also we had to tune certain parameters like what should be the executor size, what should be the memory, and many other stuff. All these things now becomes instead of a code or a configuration, it becomes a declarative pipeline. So we declare certain things that what data sets should exist and how to compute them. That's what this SDP does. And the framework, which is the Spark Declarative Pipeline framework, it figures out when to run each of the steps, which steps can be run in parallel, which can be sequential. So it identifies all those things and then it runs it on the Spark cluster, and it completely removes the need for manual bookkeeping. Like, okay, upstream is successful, downstream is successful. When upstream gets updated, downstream also needs to be updated. So those kind of things, and we no longer need to manage states of already processed files. It also opens up the possibility of combining streaming table with batch ones, so that we can uh, have a unified view. Or for example, if we in feature stores, we have two layers. One is streaming layer, one is batch layer, which does the same computation. So in using this, we can even optimize that to have a unified layer, which does where Spark is the computation. We define the logic once, and it runs with both streaming as well as the batch cases. And then behind the scene, the declarative pipeline framework, we create a data pipeline which orchestrates everything. It will create some abstractions and determine the most efficient method or most efficient way to run those tasks in parallel or sequential, depends upon the task how we have created. So declarative pipelines handles dependency resolution, execution, plan generation, incremental and streaming logic, monitoring, retries, and fault tolerance. So this comes out of the box. So in summary, we have what we do is we describe a data flow graph, which is tables plus views and the queries that produce them. SDP plans the execution order and parallelize itself safely. And then if we have batch or streaming use cases, it combines them with familiar Spark APIs. One thing to note is Spark SDP is only available in 4.1. One thing to note is what Spark SDP is not. So Spark SDP is not a scheduler. So Airflow, Daxter, Prefect, or whatever we are using, they will remain where they are, and that we have to call. Let's say if we are using an ecosystem service, for example, Airflow, we have to call this SDP from that particular point. So that is one. It is not tied to one table format. So it can use any sources. It can support incremental features for Iceberg, Delta, Hoodie, but there is no lock-in. It works with everything. And other thing is it's not a silver bullet for modeling. So we still have to design our own schemas. We still define the contracts and everything. So don't treat this as a silver bullet which will solve every problem. It is just a new way of defining or declaring the pipeline that we want. The model, the SDP follows following. These are the main components basically. So flow is unit of work that writes to a target. Target can be a source. Means target can be a data set. Again, data sets is nothing but what flows produce and other flows can read from. So for example, if we have one flow can read from a data set and does some transformation and produces a data set. So that's how these flows and data sets are related. A streaming table is for incremental changes. Materialized view is for batch, where one flow writes it. And temporary view is for logical intermediate data that we have, and it is scoped to a run. So if the once the run is complete, these temporary views are gone. And the pipeline is a project with definitions like in .py or .sql, and then we will have a YAML spec which says okay what how to arrange them, and STP will automatically analyze the dependencies and executes the graph accordingly. So if you see the hierarchy of these components, dataset has two different types of tables. Like datasets can be of table or a temporary view, table can be a materialized view or a streaming table. How do we define this? It's pretty simple. So we can install this as a PySpark, and we provide the pipeline option to install the pipeline. It also will have certain what you call dependencies automatically installed, like PySpark Connect will be automatically installed when we install this pipeline, and then from pipeline we can import these pipelines, and we have in the pipeline, if let's say if we name it as TP, we have table decorator, we have materialized view decorator, we have append flow decorator, we have temporary view decorator, then we have option of creating stream table, creating auto CDC flow, creating sync. So these are options in the API, but also we have same options available in the SQL as well. So for example, we can say create or replace streaming table, whatever name that we want to give, and then so that is how we leverage that. One example is that for example, it has all the things like how we define a table. So we say that, okay, I am reading a raw table, which is tables 5 location. We say that, okay, read this path and it will give me the table definition. Then we say, okay, filtered table. So here we have something called filtered, where we are saying filter on this partition column and mode is override. So it will simply read that table and return that filtered part. We can aggregate, we can do a roll up flow name, we define the flow name, we give the pipeline name, and targets is the rolling 7 day. So we want to get this 7 day, but it depends on daily KPIs, or it depends on something else. So because here we are calling daily API, so this will also be executed. But and daily KPIs depend on table filtered, so it will also execute this. And table filtered depends on table raw or sales raw, table raw, so it will also call that function. So this way it will execute all those in order that they have to. And then we have to, if we have to define, we can simply say what are the pipelines YAML, like or what are the files that we have to include. So this py file, or let's say if we have SQL, we have to define that, and then we say what catalog, what database, and whatever configuration that we want to pass explicitly, we can pass that in here. And then once we have this pipeline ready, we can run this using this command, which simply says dry run, which will simply not do anything. It will just do a syntax check and validate the graph. And if we execute the pipeline, it will simply say run and provide the spec, which is the pipeline.yaml spec, and it will start running that. And this is what I was saying, that we have to install PySpark, and if we provide the pipeline option, it will install the pipeline thing. There are two modes for to running this. One is triggered, where the it processes once whatever data is available till now, it will update the MBs and then shut it down. So that is the one view, one mode. And there is another mode which is continuous, where the it will keep on, it will behave like in streaming, where wherever a change will happen, it will keep on updating the materialized views for us. So that are the two modes. There are few things like never use some methods which save or write to files or tables as part of, because it's already have concept of tables. So when we define these tables, those are already getting written. So there is no point of writing collect, true pandas, save as table, or start to table. So those things are not needed, and we should not write that. Spark Declarative pipeline works with Spark Connect. This is one hardcore dependency that, okay, it is as of now, it only works with Spark Declarative pipeline or with PySpark Connect. It works with other, because it in behind the scene it uses Spark submit command itself, but uh, I have not tested it without Spark Connect. So just keep in mind that this is only for in my testing, it is only works for Spark Connect, but it should not be any issue, because this SDP pipeline, or this command, which is in Spark pipelines, behind the scene it uses Spark Submit itself. So that should not be issue. But in case of it is running with Spark Connect. How it works is Spark SDP will translate the CLI command into a proto command and send it to the Spark Connect server. Using the gRPC framework, the pipeline handler in the Spark Connect server translates it to the protocol, which is protocol buffer, to and then it will the pipeline handler will retrieve the data flow graph associated with the data flow graph ID sent by the client, and then it will do based on the graph's data flow definitions, it will create a logical plan, then it will hand it off to the catalyst optimizer, where the rule based optimization will be applied. whatever like predicate push down projection including everything will be done, and then optimized logical plan will be sent to the physical planner, and physical plan will execute that command, and then it will return the result. So this is what uh, a quick overview of Spark declarative pipeline is. Go ahead and try it out and keep rocking. Thanks.